In part 3, we will take a quick look at the basic units of measurement used in science. If you are in ATS 101, this will be treated in greater detail, so this will be a very brief overview. The unit system for science measurements is based on the International System of Units, or the SI units. The base quantities that we have are length, mass, time, and temperature. Now we'll look at temperature in more detail in Chapter 3, but we do want to touch on it here. Base units of meter, and the kilogram is the actual base unit we use for mass, although gram is the root of that. Time in seconds, and temperature in Kelvin. Abbreviation of lowercase m, kg, s, and then capital K for temperature for Kelvin. The basic unit of measurement for length is a meter. This is defined by an international agreement that in 1983 the group defined it as the distance that light travels in a vacuum in 1,299,792,485th of a second. That's related to the speed of light. Before this, there was an actual physical measure that was used. This allows the measure to be a free unit that is not dependent upon a physical measure. It's based upon a fixed quantity, so it's always remeasurable. For mass, the standard of mass is a kilogram. There's actually a block of metal that's kept at the International Bureau of Weights and Measurements in France, and a duplicate of that is kept at the National Institute of Standards and Technology, the NIST, near Washington, D.C. So these two are meant as the standard for a kilogram mass. There is another way of defining it and calculating it, but that's sort of the base that it's used. Time is now based off of the atomic clock. So a second is defined as the duration of 9,192,631,770 periods of radiation emitted from a certain transition within a cesium atom, a cesium-133 atom. So it's based on a nuclear reaction, actually. That's why it's the atomic clock. Now, just to touch on this, when we're measuring mass, when we're measuring grams and kilograms, kilogram is a measure of mass, which is actually different from weight. Mass and weight are not the same thing. The mass of an object is simply the measure of the quantity of matter within an object. Its weight is dependent upon the gravitational pull on that matter. Now, here on Earth, that's pretty much a constant, and so we use weight and mass interchangeably, but they're not necessarily. Weight is dependent on gravity. Mass is a fixed quantity, does not depend on gravity. So if you go from Earth to the moon, your weight will change. The moon's gravitational pull is about 1/6 of that of Earth's. So you would weigh 1/6 of what you weigh here on Earth if you went to the moon. However, your amount of mass would not change. The amount of mass remains constant. Now, in order to get from our base units of meters or grams or liters, whatever we're measuring in, we use prefix multipliers in the SI system. So in the metric system, we're going to start with some base, and then either we're going to make it larger by units of 10, it's a decimal system, 10, 100, 1,000, so on and so forth, so we multiply up, or we can divide by those values and move down, smaller numbers. Okay, so a centimeter is 1/100th of a meter. A kilometer is 1,000 meters. I move up or down from the base units. Okay, so you probably need to get familiar with these prefixes and the symbols, particularly, let's start with tera, giga, and mega. You may already be familiar with as computer terms, If not, those are terms we will see on occasion, so it's probably good for you to be familiar with those and at least have an idea what those mean. Kilo, you will definitely need to know that it means, 1,000. Deci, you may or may not see. Hecto and deca, not so much. Centi, you will use. Centimeters, we use a lot. Milli is one that you will use. Micro and nano. Okay, so definitely know those. I'll go through them again here. Definitely know kilo. Definitely know centi, milli, micro, and nano. Those we will be using throughout the semester, so be sure you know those. If you're not comfortable with using these prefixes and you need a little more instruction on that, please come and see me on that. Again, you'll see it again in scientific math. We're covering it heavily there. If you need some help outside of that, just send me an email or give me a call. We'll work through that. Okay, so how do you decide what multiplier to use? Well, you use the prefix multiplier that seems to be most convenient for whatever measurement you're making. So you want to pick a unit that's similar in size or maybe a little smaller than the quantity you're measuring. So for example, if we look at chemical bonds, that's the energetic bond that holds two atoms together in a molecule. A short bond is about 1.2 times 10 to the minus 10th meters. Okay, that's well and good, but that doesn't really mean much just looking at that number. It's kind of hard to wrap your head around what that means. So in other words, you're moving this decimal point over to the left 10 places. That's a very, very small number. If we want to put it in terms of a prefix multiplier, something that we can wrap our head around a little better, I want to look and see which multiplier gets closest to what I have. So 10 to the minus 10th, if I look, these go in units of 3. You'll notice that all of those went in units of 3. So the pico is 10 to the minus 12th, nano is 10 to the minus 9th. Which one would I want to use? Well, the most convenient one is probably going to be the picometer. Okay, just because it's at or a little smaller. Okay, so, and actually when we've got these negative values, the bigger the number here in the exponent, the smaller it is. So you might find it easier to go that way, because if I use nano, what I'm going to have to do is move my decimal point over here, and I'm going to have 0.12 nanometers. And we like to keep, at least a whole number integer value in there. So if I use pico, okay, this is 10 to the minus 10th. I go over one more, 11 and 12. That gives me 120. So 120 picometers, which pico, okay, again, this is going to be, nano is a billionth, so this is a trillionth. 120 trillionth of a meter. And just a note about volume. Volume is a derived unit. It's a unit formed from other units, so volume is not a base unit by itself. Many units of volume are measures of space. Okay? So area is the length times the width of something. Volume, length times width times height. So any unit of length, when you cube it, raise it to the third power, you get a unit of volume. So we can have cubic meters, cubic centimeters, cubic millimeters. These are all units of volume. Now liters are also a unit of volume, but they break down to these sort of measurements: cubic centimeters, cubic millimeters. A liter is actually a cubic decimeter. So it doesn't really act as a base unit. Volume is what we call a derived unit. We want to keep that in mind, because you may see volume expressed in terms of liters and milliliters, or you may see it expressed in terms of cubic centimeters, cubic millimeters, cubic meters, cubic decameters, whatever we've got handy to us. Okay, so just a few notes about the SI system and units. Again, if you would like to know more about this, contact me. Check out the Scientific Math Blackboard site.